Now, we recently changed the name of our department to ECAMS, Engineering, Computing, and Mathematical Sciences, because engineering has become an increasingly large focus, an increasingly important focus of ours over the course of these past few years. Computer engineering started here about 5 years ago. It is an outstanding program that focuses on embedded systems and the Internet of Things. And what this basically means is you are focusing on designing, building, deploying, testing devices that are computer controlled. They respond to sensors, or they respond to inputs in their environment, and in a software powered kind of way respond to those events by actuating motors or electrical impulses or whatever to try to affect change in the world. That's what IoT is about. You're creating, designing, deploying, testing these kinds of devices, and that requires you to become an expert in hardware and software design, testing, and application. It's a truly timely, highly relevant, extremely fun, and hands-on discipline computer engineering is, and it's made possible to you through a really great curriculum that teaches you how to research, design, develop, test, and oversee the manufacture of computer hardware, how to design and test circuits, how to build computer networks, and how to work on the interface between different pieces of hardware. Because as we all know, seldom do you find a single device that operates just as an island, just on its own. Typically, these devices need to interact with other devices, and so as a computer engineer, you learn how to make that happen. So as a computer engineer, you will learn to specialize in artificial intelligence, operating systems, networks, how to design computers and the chips inside of them, including the microprocessors, how to design computer software. You might not become as adept as a computer scientist would be at writing software, but then again, you might become just as good as a computer scientist at writing software. But the point is, the writing of the software wouldn't be for commercial applications you were trying to build, but rather so that you can make the hardware do your bidding, do what it needs to do at any given time to carry out a plan. Where this all comes together, interestingly, is in the field of robotics. We have a robotics lab here on campus that students can use to 3D print parts for robots, assemble them, actually integrate them with Arduino chips and Raspberry Pis to get them to respond to sensory inputs and then test the robots. We have a robotics lab here on campus. And what's really cool about the field of robotics is that all this stuff you're learning in the rest of the computer engineering curriculum really comes to play in there. So it's kind of special that Lewis has a robotics lab here that you can use.